We're going to have today we're going to have a fairly busy morning with a sort of material that didn't get covered within the first 5 days. And I'm going to start with a retrospective, and then we'll go on to a set of new material. So yesterday, we started the day with a couple of intertwined topics, most notably the issue of exporting data from our models, collecting, storing, and exporting data from models. And I also tried to weave in there some issues of user interface. How do you add user interfaces to a model? So we're storing up, we're collecting and storing up data and exporting it. We saw that there were a variety of mechanisms. Some of these mechanisms required forethought. So examples would be provision of data sets to accumulate information, creating statistics, for example. Some of them could be explored in a purely ad hoc manner. An example would be putting on a variable in any logic that's updating a request to see a graph of that as while it's running. You can export that to Excel, for example. And that's valuable. But we saw that AnyLogic provides a set of additional capabilities based around data sets of a couple sorts. We saw a regular data set that was indexed by time. We saw a histogram data set, for example. And we saw that there were that those could be powerful vehicles for accumulating information in certain sorts. Histograms of values over time, or histograms concerning the population at one point in time. But we did see, like in many areas of AnyLogic, that you've got to be willing to write maybe 2 lines of code to use those histograms, or 3 lines of code, and hopefully example models that we've provided, including those created yesterday, that are provided as part of the ODrive, will give you a leg up in doing that. Normally it's something like a loop over the population under each successive method, doing something like adding them into the histogram data set. On the other hand, regular data sets can often be used without writing any code whatsoever in sort of our normal sense of it, just saying what you want them to record. We did also see statistics, a very powerful tool that has its limitations, but is a big step up from having to go write the code de novo. So with statistics, for example, we could say we could specify a statistic, a custom statistic, count the number of women in the population, number of men in the population. Or we could ask it to count up the number of people who are in this certain disease state, for example, people who are falling in an age range, etc. And as we'll see in a performance lecture that I give today, statistics do have their limitations in terms of performance. They require sweeps over the population. And sometimes you end up doing 17 sweeps for age categories, 5-year age categories, 0 to 80, and then one for grab that for 80 plus. And you do a sweep for each of those categories rather than just in one sweep dividing people into each category clearly. This is something AnyLogic is going to be working on in later versions of the software to take better advantage of that sort of the logical structure of what you're trying to do. But right now, it can be performance hungry if you have a lot of statistics. And so later I'll talk about ways of sort of dealing with that effectively. But statistics are very powerful for several reasons. One thing is you define your custom statistics using whatever criteria you want. Number 2, those statistics can very easily be used by a variety of other mechanisms like data sets, like charts, etc., like those time plots that we introduced. Number 3, that information on the statistics is actually available to you interactively as you run the model by clicking on population, clicking on the enclosing, so-called embedded object. And if you have this population, it'll be summarizing the statistics for you, recalculating them as the model goes on. And that can often give you feedback about what's going on in the model, even if you don't have a graph for that. You can get some sense from watching those statistics. We saw that statistics could get ugly in terms of requiring you to write some fairly long expressions. And in the Java tutorials, we talked about a way to lessen some of that ugliness by going and inserting a function within, say, the person, which computes something, for example, is infected, and that function would take care of checking whatever needs to be checked, if they're in one of these two states, or if they're in this state, or a certain variable is true, or what have you. So sometimes you want to clean that up and just have it pull up to a method for that person. So the statistic then is just item dot is infected or is male or what have you. So these are things that will sometimes make the statistics more intelligible and more scalable in a sense by eliminating large sort of expressions. So anyway, statistics are a very powerful tool, but we did see how they can be linked into these additional variables. And then with a bit of stumbling, we ended with some suggestions, for example, from Ruhud on the need to close explicitly the file connection. We did, were able to export data sets straightforwardly to a file. This is something which can be done manually and interactively by clicking on those data sets, right-clicking, and so seeing the data, right-clicking, and copying to Excel. However, if you have a bunch of data sets, which I often do with my model, accumulating different aspects of model operation, it's useful to export those data sets to a file all at once. So you have 10 data sets exported at a single time to a capital limited file that you can then read in with R or with Excel or MATLAB or whatever your workplace is. We saw that the built-in statistics summarize the state of the population at a given time, but they don't really provide a good mechanism for asking about what I call flow statistics. How many people, for example, contracted this illness within the last 30 days. If you want to do that, you'll find lectures from me on my YouTube page about building techniques for flow statistics. If there are real interest, I'd be glad to do it in front of you. Give you an example of that. But the fundamental idea is you have to do a little bit of work yourself. It's a very, very small bit of work, but basically build a variable to count this thing and then report that variable periodically. One thing I didn't mention yesterday, but it bears noting, is that frequently when we're collecting and exporting data, we do so at defined intervals. So in the ODE protocol, this is what's called observational processes. So we have some epiphenomenal processes. By epiphenomenal, I mean they don't affect the underlying dynamics of the model. They just observe the model. And these processes are running, and often what happens is you collect data at some fixed intervals. Some of the data collection mechanisms provide an automatic way of doing this. For example, with a data set, you can say, collect the data in this data set every so often with a recurrence time is the label for recurrence time of X. But others, like statistics, you put them there, tells how to compute it, but it doesn't directly tell, you don't tell any logic associated with this, how often to do that. If you want to compute the statistic periodically, you can do so with an associated data set. Alternatively, you could have an event, for example, that fires periodically, computes the statistic, and exports it to a database, something like that. Okay. We did see, although we didn't explore them, that AnyLogic also has some quite sophisticated mechanisms for interfacing with Excel files, for example, to access data in Excel files, to bring it in, or to write data to Excel files. So, you know, if that's a valuable tool for you, you might want to explore those mechanisms. And if there were real interest in people here, you could probably put up a little example which does that, and read some data in from Excel and exports data out to a different sheet of Excel or what have you. I'm glad to do that if there's interest. Now, all through that process, ladies and gentlemen, we were further looking at building user interface widgets. What were some user interface so-called controls or widgets that we put onto our model as part of this process? Buttons and sliders were the two main ones. We also put on a kind of single, a static use of labels, just to sort of label, the purpose, say, of a slider. Labels could be dynamic. You can actually go update that label to change over time, print out, the location of the person with the highest income or whatever, if you wanted to. All those things are dynamic. We saw that sliders are particularly easy to use by virtue of their capacity to declaratively be specified to link to a variable. So you could say, link this slider to a variable or to a parameter to change that parameter over time. If that parameter changed for other reasons, the slider will be automatically updated. So it's a bidirectional connection. Change the slider, change the parameter, changes the slider. This is a powerful thing to decrease the complexity required to build up the model. Those are some examples of user interfaces that could be provided, user interface widgets or controls that are provided. There's a variety more of additional ones, drop-downs, radio buttons that can let you select different options, check boxes. You can have edit boxes where you type in, for instance, the purpose of a model run, and it writes it away to your text file when it outputs the data. So you can look back at these text files and remember, why was I running this? What was the purpose of this run? What was I seeking out of it? Or it could be a brief summary of the assumptions behind this run that you're investigating in addition to any data exported. I did note, and I want to emphasize it again, it almost can't get enough emphasis at this point in the modeling process. It's extremely important that you output not only data from your model, but metadata. Give some examples of metadata that you might want to that I argue you might want to export. I just mentioned one. Parameter values, so the assumptions behind it. Model versions would be another one. Another one would be the purpose of model runs, so what you're investigating, seeking to investigate here. When you look at data a month hence, or 3 months hence, or 6 months hence, or a year hence, having that sort of documentation is absolutely key. And you want to maintain some form of kind of lab notebook or some way of kind of linking up what you did to what came out. Hopefully knitting through that whole process so that if you later when you produce graphs from R or you summarize the results across multiple scenarios in Excel, that all those sheets that you use to examine it, and maybe all sources for parameter values you used, maybe it was from a meta-analysis you found that went into this model. You like a way of weaving those together. And our team actually did, a number of years back, create a tool for doing this in AnyLogic, which if people are interested in seeing, we'd like to show. Unfortunately, the student, as is the nature of academia, the student has gone on and is a professional software developer, and has, I'm told he's sleeping 3 hours a night or something, and he doesn't have time to maintain this code base right now. The good news is AnyLogic is putting significant efforts into the whole the whole thing of the whole issue of scenario management. So building into any logic an interface to maintain information on the assumptions that went in the model runs and the results from those, and hopefully ancillary files like output analyses and files that were used to derive parameter values or et cetera. And hopefully in another full release of any logic or something, we'll have a tool that provides much of that functionality, and critically, like our tool, allows you to have groups who are not co-located to all collaborate on one model, see all the runs run by other people, and see the results from those runs.
The scenario manager for any logic is the first thing that's planned after the release of logic 7. As far as I understand it, our goal is to have that out within 1 year.
Great.
That's like probably 7.1, 7.2 will be the scenario manager, which will be a huge step forward. I don't know about, real-time collaboration of that kind of stuff. But if you can, for example, use SDI-CDS to actually connect with the scenario manager in addition to the actual model, that would basically be one of the out of it. But I do know that logic 7 is released hopefully in December. We'll be commenting on exactly what you've seen already. And then the next thing that developers are working on is that scenario.
That's good. That's good. Appreciate it. And I know that the mothership is spending a lot of time trying to think about how best to take advantage of those capabilities, and is putting effort into this whole idea of how to support teams of people who are located in different areas of space. People, maybe it's in the offices, different offices in the same building, or maybe it's people scattered throughout the world who are all working on the same model, maybe changing different parts of it, maybe each doing different runs with it, and they want to share their results. They want to see the findings from each other's runs and sort of comment on them and mark them up. And I know this is a point of considerable interest. In this day and age, how many people here have used Google Docs? Okay, so quite a few people. This day and age of remote collaboration in a rich, interactive way, there's a real premium on sort of allowing people to seamlessly contribute to an underlying artifact, in this case a model, in a way that maximizes the ability to do that simultaneously. It doesn't require merely a lock, I've got it for the next day, then I'll pass it to you, but allows you to kind of interactively see what other people are getting. And this is something that any logic is tracking and trying to figure out how to take advantage of most effectively. And I think it will allow them to stay ahead of the curve and continue to advance things on the cutting edge. So that's great. So we saw those two components yesterday. We also talked about model calibration as a topic. So the idea here was that often we have data concerning the system, which relates not to just one or two parameters in the system in a way that allows us to estimate those parameter values, but it's data instead about the behavior of a system or parts of that system as a whole, in a way that you can't untangle from it a particular parameter estimate. If you think about something like incidence, the incident case counts for disease, it is affected by a lot of things. It's affected by contact patterns, like the transmission per discordant contact. It's affected by mortality rates or in changes in risk perception. It may be affected by immigration or births. There's a lot of things kind of going into that. You can't take those numbers and directly give an estimate of contact rate. What you can do is ask your model to try to match when it runs, to adjust any unknown parameters so that it best matches that data. And in some cases, we have quite a few points of data on that. Maybe not just a case count, but number of deaths that occur per month, and maybe we have information on the fraction of all cases that have been diagnosed and infected, etc. And we want them all to match all of this. And we saw that there are several ways of trying to take advantage of this information. One of them that we talked about yesterday was AnyLogic's built-in support for parameter estimation for this, speaking of numerical analysis. And so trying to find the point prediction of parameters. In other words, the specific values of parameters that are allowed to best match the observed data. We saw that AnyLogic provides quite extensive mechanisms to do this based upon the optimization capacities of what's called OpQuest, which is a professional optimization engine used by AnyLogic. And AnyLogic can basically allow you to specify which parameters you want to vary over what range you want to vary them in, criteria that you have for those parameters, constraints about what values they can take on. It allowed you to specify a sort of way of judging how bad or good a fit is, say how big a certain discrepancy is considered, and it allows you to specify a what you're judging that discrepancy on, and moreover, it allows you to specify how to deal with stochastics. So the fact is that a model run on the exact same assumptions about parameters will typically yield somewhat different results each time. So it allows you to specify a number of so-called realizations to run, or replications in AnyLogic terminology. So to run the model a certain number of times. And there's a way of doing that so it automatically throttles that to achieve a certain level of statistical confidence in the results. By doing this, you can declaratively say, okay, I'd like to calibrate my model like this. Finally, you can specify, after it does the run, how do you judge if this is a suitable run, if it's a legal run. You may have some additional criteria for that. And we saw that AnyLogic, once again here, like a parameter variation experiment, what goes on for these calibration experiments is that one experiment runs your model again and again and again and again. It's not like our classic experiments where it runs the model once. Instead, it's running the model, grabbing some information out of it, in this case, sort of data on that to be compared with the historic data, and then it'll throw that one away and run it again and run it again. So AnyLogic provides a rich set of capacity for model calibration in this sense. But model calibration, most importantly, is not a mechanical process. It's not merely a process you throw at your model, let it run for 50 days or for 2 days, and get out a bunch of parameter values, and you're done with it. Often it's one of the biggest opportunities in the modeling process for developing insight, because it's there that you realize your model structure just doesn't cut it. It just doesn't have the requisite capacity to kind of capture both this and this. There's something not adding up. Sometimes it's an issue of how you characterize the system. Sometimes it's an issue of faulty data sources. And Scott contributed some great stories along those lines, and they align with stories that I've experienced too. Those are not bumps, speed bumps in the road to a final model. That confers a lot of the value of the process. The fact that we recognize certain data sources as questionable, or the fact that we've learned something about the way the world must work to jive with the data, that's a lot of value right there. So calibration is not a process to be rushed through. It's not a process to brush out of the way. It's a key process for securing insight, and it's one that is worth investing in to do well. And I noted that my slides and online lectures have some discussion about how to learn from it. Now, over lunch, we had a presentation on something that I feel I could have done a rather better job on within this year's boot camp, which is talking about multiple modeling platforms. Sarah McPhee-Knowles and Wan Yi shared their experience in converting a model that Sarah's been building up for quite some time now, a quite interesting model of the spread of foodborne illness and its interaction with regulatory apparati, so regulators who are circulating among stores. This is a model for insight that has demonstrated some quite interesting behavior and is already shaping in our group some sort of priorities for possible research applications of some of the tools that we work with. And Sarah shared some observations on the trade-offs for bringing that model from another platform, namely NetLogo, into AnyLogic. And there was a set of texture trade-offs associated with these that I thought the presentation did a great job of sort of pointing to. One of the most salient aspects of NetLogo is that, like AnyLogic, it does put considerable emphasis on declarative specification of certain things in the model. By declarative, I mean specify the what, and it takes care of some of the how. So, for example, graphs and sliders and so on can be built up quite easily in NetLogo. There's some other things like state charts, which are in AnyLogic, but which aren't directly observable in NetLogo. But NetLogo has some additional features like behavior spaces and so on, which are pretty nifty beyond AnyLogic. NetLogo is written not in a common language you'll go out and find people using in software development like Java. Instead, it's written on a special purpose language, what we call a domain-specific language in computer science. And this is an area of active work for our own group, how to craft agent-based modeling domain-specific languages. Suffice it to say that you can with some languages you can specify the sorts of models of building in AnyLogic much more crisply, transparently, and clearly in the right domain-specific language. This is something I should note that AnyLogic as a company is tracking, and there's active discussions about how to lower this barrier of Java and how to make it just easier to build these sort of models. AnyLogic has come a long way within the past decade. The early years of AnyLogic were a point of great learning. The earliest versions of AnyLogic didn't even have agent-based modeling as we know it today within them. And that was introduced as a result, ladies and gentlemen, of user feedback from users like you. Sort of saying, hey, couldn't we do this? This is a real priority. So as a company, they've been very responsive over the years. And I think Sarah's and Wan Yi's presentation helped highlight a number of places where things fall short. Some of them are more features that could be put in. An example would be the torus. And while tori, these sort of donut-shaped topologies that allow you to kind of, within a space, I thought a figure would be useful here in case people haven't seen it. They're allowed to, if you have a space in which agents are circulating, if an agent kind of goes over here, they end up coming in over here. If an agent kind of goes up here, they end up coming in over here. So this is connected with that, that's connected with that. That's why we say it's like a donut. Kind of wraps around this way and wraps around that way. And one of the advantages, the main advantage people use that people are seeking when building these models is it eliminates weird artifacts where someone's bumping into the corner here in a way that wouldn't be representative of the real world. So, of course, if you have a real world space, which is bounded, you can very easily simulate that with a bounded space in AnyLogic. But sometimes you want to simulate a space that's unbounded, but realistically, you're going to be able to simulate a space of a certain size. And representing a torus allows you to eliminate one source of artifacts. However, as was mentioned by Davu, you can get quite different results sometimes with a toroidal space in place or having a bounded space. And Wan Yi and Sarah's presentation brought that out, that it's not convenient, it's not trivial to implement toroids and toruses in tori in AnyLogic, and so the model version they created first has no torus, currently doesn't have a torus in it, and they found turning off the torus in NetLogo, they found a considerable difference. Turning off the torus in NetLogo brought the two models much closer to each other. So this is something which eventually AnyLogic, I'm hoping, might be able to enable. Yes.
Well, the issue is actually creating a toroidal space is not difficult.
No, and in fact, some of the models I've given, it's really things like get distance and stuff.
It's the sensing of things near you is would be the really difficult part. I definitely am taking feedback, and I would highly recommend, just so you guys all know, my email address is in the binder because I am an assistant in the boot camp. I would highly recommend each and every one of you email me with one, maybe two concepts for what would be interesting to you to get in AnyLogic that's not there now. Because then I have direct contact with the head of the company, got Course Chef, I had direct contact with developers. And as I said, we are currently, actually, Duck Course Chef last week or so has been going through our recommendations database of what should be added to AnyLogic and basically triaging them. So this is exactly the right time to come and be able to get your voice in so it can be addressed hopefully shorter time.
That's great. I'm grateful, Scott, for you bringing that sort of information back and for all your contributions and offerings to sort of field questions. It's fantastic and much appreciated. Extremely valuable. So this was one of the issues brought out by the difference. There's others though. For example, this language that is supported by NetLogo does allow an economy of expression for certain things. And very importantly, it allows you to see a model sort of all at once like that. Now we actually saw that there is something in AnyLogic that allows you to kind of browse the model all at once. Does anyone remember what it is? I showed it to you early on in boot camp. Yeah, you could do generate documentation on a model, but it's awfully voluminous right now. It goes into all sorts of sort of little nuances about the font used for this label or whatever in a way that kind of obscures what's really important and what's really sort of incidental. Once again, this is something where there's some listening going on, but where I think there's a big lesson learned. Being able to sort of crisply look at a short statement of a model and understand what's going on is sort of the name of the game. And this is, as I said, a sort of focus of some of our work. And I think there's a big virtue there to not only have graphical depictions like AnyLogic provides of state charts, but to have a way of kind of summarizing it really, really quickly. So this generate documentation really knows another thing that they're working on. But the NetLogo comparison I thought was very, very apt and very, very substantial. An interesting point though that was emphasized by Sarah is sometimes if you're going to build the model, often, and this is something that came up in a remark of a conversation with Gerhard here in class a few days ago. When you're going to build the model, there's often a little dance that goes on between what requirements you'd like to capture, what you'd like to do with it, what research questions you seek to identify to address, and on the other hand, what's easy to do, what's feasible to do, given your skill sets. And you often may end up emphasizing this research question, this formulation, or this simplification, this specification of the model, because it's really straightforward to do in your model. It's conceptually clear, it will lower the risk that you have some bug, etc. And so the comment that was made by Sarah is, there probably would have been a different model produced if this model had started in AnyLogic than if it started in NetLogo. And neither of them is privileged in a sense, but it is an interesting comment on sort of some things that are easy in one framework, hard in another. The primary issue with NetLogo, if anyone's interested in this issue more and are interested in seeing more examples on a smaller group basis, I'd be glad to show it. We're right now comparing systematically a single model, it's a different model, across 5 different options for implementing it. So we have it in AnyLogic, we have it in NetLogo, we have it in ModGen, we have a Python version, and we have a Scala version. And we're interested in comparing sort of the ease of representing the model, the clarity of the model, transparency, as well as performance of the model, scalability. The real challenge for NetLogo, which they're working on as well, I think, is all of your scalability. How do you make this be able to handle a very, very large number of agents? There are ways of doing that with a high-level language, but a lot of what the challenge is that that right now the way of building the model is leading to a quite slow sort of implementation of how fast it runs and how effectively. So for this project that I mentioned preparing, it actually started in NetLogo early on. That was where it started, but at some point it just became, we couldn't do the requisite charts to visualize it, which is too complex, and it couldn't handle the large number of agents. But again, this is something NetLogo is working on. So both of these are moving targets, and it's great to have competition in this space. It's my firm conviction that NetLogo is right for some people, not for people. It's right for certain types of questions with certain types of people, with certain backgrounds. And if people are interested in seeing actual code, like what does code look like in repass for a same model that's an end logic that you could look at, come speak with me, because I could show you these things on a smaller basis. Okay.
Sorry, Dr. How
Yeah.
does Arena fit in that?
That's a great comment. So I have not heavily used Arena. It's a tool that I'm not aware that supports system dynamics modeling or agent-based modeling in its full capacity. I think it's predominantly a discrete event modeling tool, and it's very specialized as such. If you are seeking specifically to perform discrete event modeling, and you're not seeking to take advantage of some of the special features that AnyLogic provides by hybridizing that. For example, if you wanted flows of patients through a hospital wards and getting them triaged and so on, you want to represent something like that trauma center model. In and of itself, it could be, I think, a quite powerful vehicle for doing that. And maybe Scott is someone who could comment on the trade-offs. However, what AnyLogic would allow you to do beyond that would be something like, particularly with version 7, specifically with version 7, when two people are in close proximity, there might be interactions simulated between them, exchanges of information, exchanges of attitudes with respect to, their treatment that might lead to changes in behavior, and also potentially transmission of pathogen or something like that. So, AnyLogic does provide a set of additional flexibility in terms of keeping track of information with these entities that flow through, information on statistics that report their sort of history of treatment and so on. And it allows you to hybridize it. But if you were just seeking to do one type of modeling, there's a bunch of discrete event modeling packages out there, some of which are quite formidable. Arena is one of them, but there's a variety that have different uses. Also, there's some packages which are more used for process simulation in a continuous sense. Like if you were simulating a chemical plant where you have large flows of chemicals from different sources and they get combined, different products from them get used. That's also something where there's some specialized software like Aspen's Tech. I think Aspen Tech is Super Tech or Super Sim or something like that I've heard quite a bit about that can be used to simulate these sort of continuous flow systems. But I'm not an expert in Arena. It is something that has been traditionally taught to students here. My distinct perception is it's basically quite specifically discrete event modeling. Scott, do you want to comment on that at all?
Actually, I learned discrete event simulation from Arena. That is I hate to say industry standard for discrete event modeling. Arena is fairly good at discrete event modeling. However, it can only do discrete event modeling. It's not object oriented. It has its own programming language with signing that underlies it. So it is a complete bear, and that is a euphemism for extending it beyond what it can do. Now, currently compared to any logic, I have a document that I cannot show you that explains exactly point by point the differences between the relative strength and weaknesses of any logic and arena. Arena is something of the grand old lady of discrete simulation. It is probably has the largest market share, and every other discrete event simulation tool, including any logic, basically fights over the people who don't want to use arena anymore. That's almost, to my sense, the market, at least for discrete simulation. I will tell you personally, I will never use arena again as long as I have access to any logic. And I say that as someone who has more experience using arena than anyone. Okay, I will absolutely never use arena again.
The market is all about, they want to down develop and then eventually because of the least response.
Yeah, the problem with arena is that it is hitting its barrier of what widgets it can produce. I mean, the whole idea that they decided not to become more object-oriented, and so the person who created Arena, Dr. Pedgin, has made his own software, Simio, which builds itself as object-oriented Arena. Okay, that tells you the extent to which Arena is probably going to die, and probably in the shorter term sense, in the longer term sense. Speaking about Simio for a second, Simio is probably the closest to Anilog in the sense of doing hybrid modeling because it can do some agent-like behavior because you can attach its own processes to resources and not just entities. But basically, Arena, just to get back to Arena for a second, Arena has every single strength and weakness of discrete simulation. It is a pure discrete simulation tool. It does have, I think, a custom library for continuous process modeling, like oil fracking and all that kind of stuff. But the point is that you have no autonomy in the agents, you have no autonomy in the resources. So while it might be useful for a manufacturing sense, in the healthcare sense, it's a complete bear to do anything that does not that even remotely falls outside the context of pure discrete simulation.
So, for example, if you wanted healthcare workers, each of which has pairing with certain subsets of patients, so that when a patient has seen a healthcare worker previously, say a doctor, when they come back, they see that same doctor. That would be
possible, but I would really not want to have to model that. Yeah. That has to do with resource set. No, I'm talking more like what happens when the patient refuses to do what you want them to do. If you make a discrete model that has to do with a patient taking his medication, you have to build the process so that some percent of the time when they're supposed to take the medication, they don't. Okay, as opposed to an agent-based simulation, which could be, I'm really tired today, so I think I'm just not going to deal with doing that. That's the difference between those two. And so if you have the data on preference or discrete choice theory and that kind of stuff, you can make a much richer model by either making it an agent-based model or by hybridizing your discrete model.
So in other words, instead of imposing just statistics on it, some fraction of the time they don't take the meds, make it depend on aspect of their context, which may be shaped by their experience in the system.
Right, and so I'm not saying you can't do an Arena, but the only person I know that still uses Arena is one of my professors who also is the CEO of a consulting company. And one of the first things she did is she built her own interface for Arena called Ariana, which actually came back to her daughter, I believe. But my point is, she doesn't use Arena so much. She built a front end that basically does a lot more than what Arena can do and just uses Arena as a back end sort of for simulation. So, I'm not going to come up here and tell you should not use Arena, but there it is. And particularly, at least in the industrial sector, I believe that any logic is not quite more of magnitude cheaper, but close. So, there are all kinds of trade-offs to look at. So, yeah.
So great question. So any further? Well, I guess I should mention in the afternoon we did have a brief description of two things for Java. One is functions, showing how we could build functions in any logic, which are absolutely key for sort of clean building a larger model. So we hide some code within functions we can use for many places within a model. We could pass information to these functions, what are called arguments or somewhat confusingly formal parameters in computer science. So we pass information in needed for them to do their job, and they can do their job, and we can call them with a nice name, hopefully, from many places, and if we have to change the underlying code, instead of having to change it at many, many places wherever it's used, we change it at one place where that function is defined. So we can define functions just like we can define statistics, and that helps us when we look at whatever code we have to write for a model. It'll be much easier to understand. Instead of just putting all the code there, you divide it up into calls to certain functions that do something, and if you need to, you go look at it. Otherwise, you just satisfied from the name that, okay, it's going to do the right thing. So it's separating the what needs to be done from the how. Okay? So you use them to hide the how, and you can go look at them if required. We also saw how this notion of 20. We also saw how this notion of subtyping or subclassing can be brought into models. So it turns out, and any of you might want to listen to my lecture from yesterday on this. It turns out that all of our models in any logic are being built in an object-oriented foundation. There's this sort of wrapping up of objects where they have some amount of information. Think about the properties of a person, like they're as defined by their parameters and their current state, and that's wrapped up with how they evolve, sort of the rules for evolution, of behavior. It's all wrapped up together. Any logic is built atop a foundation which uses this more generally, and occasionally, quite often actually, if you're working with a big model, you'll see some interesting things. For example, you'll notice that when you say, my person, say person is the agent, it could be here. I have a reference to person, and I say connect to. What it's actually expecting here is an agent. Now you may give it another person. You may say, offspring.connect to mother, for example. And that's a person, but that's fine, because a person is an agent. Similarly, if you want to ask for my first connection, I can say, so if I have a reference to a person, I want to ask for their first connection. I can ask, get connected agent, and ask for agent number 0 because it starts at 0. And this will give me back a reference to that person that got connected. But it will actually give me back what it knows is an agent, reference to an agent. I know it's a person, and so sometimes you're going to have to do what's called casting. You're going to have to say, treat it as a person. I know it's a person. It returns a reference to a person. I know that. But it's actually returning an agent. And this is because all persons are agents, and any logic created this method long before you created your model, and they didn't know what you'd be calling your agent. It returns an agent, and they require you to sort of say, yeah, this is a person. If you want to treat it as a full person, you can do so. So in any logic, there's this whole hierarchy. All your agent classes, like person, etc., are agents. And agents, it turns out, are what are called active objects. They can be visualized, they can be embedded, etc. And this is a little bit confusing unless you spend a little bit of time learning what this really means. It's extremely powerful, but it can be confusing if you haven't seen it before. So I gave a little lecture on what that means and how ubiquitous it is in any logic. For example, the fact that we can embed any agent in any other agent is a reflection of the fact that they're superlactive objects. So we can have populations of agents, we can have agents, and they can all have visualizations. We can have multi-level hierarchies where we have person, neighborhood, schools, cities, etc. Within our models, we have that infrastructure, and what's happening particularly with AnyLogic 7, is bringing respect to a facility that was already there with AnyLogic, what's called subclassing. So here, you can create, for example, a person agent, and you'll have a set of characteristics that are common to all people. Maybe it's they can be smoking or not. Maybe it's they can they have a certain age. Maybe it's they have a certain vaccination history. And then you'll have male and female classes that have distinct sort of attributes on a sex-specific basis. So if we're dealing with HPV, for example, there's a whole set of issues that females face in terms of risks of cervical cancer and so on that are not present on the male side. And so we might have special characteristics here having to do with cervical cancer screening testing for HPV virus as well as pap smears, etc., and progression of stages of early stage cancers, etc., and need to catch them. Whereas on the male side, the situation is simpler with stage rate. So with any logic 7, this sort of characterization where we can have a taxonomy of things and implement common things in one place instead of having male have a state chart about whether they're a smoker and female have a state chart whether they're a smoker. We just put that sort of information in person. We say male inherits it, female inherits it. In other words, female builds atop of it, male builds atop of it, but they have all these original characteristics, common characteristics that are common to all people. You can imagine similar things for a hierarchy of doctors or a hierarchy of health service personnel more generally, or a hierarchy of types of models of vehicles or what have you. You have a taxonomy, and you can capture that taxonomy in an elegant way that avoids you having to re-implement certain things that are common across multiple agent classes. Instead, you have them so-called subclass or common class. And then they can be passed around as if they're an instance of that common class. So if we have something that prints out for a person what their vaccination history is, or prints out for a person what age category they're in, or what have you, summarizes the population according to age category. That can operate on males and females for all males and females. They just have this extra piece of information that is specific to their context. So we saw that that's so-called subclassing, and in any logic 7, this is really coming to the fore. It's no longer sort of the neglected stepchild of the software where you can do it, but you got to kind of hold your nose. But it's now going to be very elegant, very straightforward, and well supported both graphically and in terms of sort of the underlying mechanisms. So I gave a glimpse of that yesterday, showing what it's like in any logic 7. If any of you have an urgent need to do that in any logic 6, I can show you how it's done. There is a way to do it safely and reliably, but it's not that pretty, to say the least. Okay, so that was a retrospective from yesterday. Any questions, comments?